To calculate the wavelength of a spectral line from an energy diagram, essentially you are being asked to use the Planck relationship, which you might remember is that the energy, there it is related to the Planck constant times the speed of light over the wavelength. Okay, so if we are asked to calculate the wavelength, we're just going to have to rearrange this so that wavelength is a subject. Okay, so wavelength is going to equal h times c over e. Okay, so Planck's constant is 6.626 times 10 to the minus 34 joule seconds. Speed of light in a vacuum is 2.998 times 10 to the power of 8 meters per second. So to work out what your energy difference is going to be the final energy state minus the initial energy state, because we know that energy is a state function. Okay, so an absorbance will be like what is pictured here, going from a lower level in energy where A is to a higher level in energy, because when we do the final energy state minus the initial state, we'll get a positive value for delta E. Remember that from thermodynamics? It wasn't that long ago, right? So I'm reading C from this diagram as 550 zeptojoules, whatever that is, minus the initial energy state, which looks like it was about 100 zeptojoules. Okay, so my difference in energy would then be, let's see, 450 zeptojoules. So my next problem is then, what is a zeptojoule? And luckily, the question actually tells us that the prefix zepto means 10 to the power of minus 21. So I can actually write an equivalency that 1 zeptojoule is equal to 10 to the power of minus 21 joules. That's going to help me out. And lastly, I'm asked for my wavelength in nanometers, so I should write the equivalency between nanometers and meters. 1 nanometer is 10 to the power of minus 9 meters. So now I'm ready to go. I can just substitute into the Planck relation. Okay, so H 6.626 times 10 to the power of minus 34 joule seconds times the speed of light, 2.998 times 10 to the power of 8 meters per second, and that'll be on the top, divided by that energy I found, which was 450 zeptojoules. And I can just straight away convert zeptojoules into joules using a unit conversion factor, that 1 zeptojoule is equal to 10 to the power of 21 joules. Sorry, 10 to the power of minus 21 joules even. 10 to the power of minus 21 joules. And then lastly, to convert between meters and nanometers. So I want my meters to cancel out, so that's going to go on the bottom. So 10 to the minus 9 meters goes on the bottom, and 1 nanometer goes on the top. So if I look at my units and just make sure everything is cancelling out as I would expect it to, I will see that those pesky zeptojoules is going to cancel out. And my joules is also going to cancel out, and my seconds is going to cancel out, my meters is going to cancel out, and I'm just going to end up with my answer in nanometers, and I end up with an answer of 441 nanometers. And that's all there is to it. So just remember, if the arrow was going the other way, like say from B to A, that would be an emission. The final energy minus the initial energy would give me a negative number. So delta E would be negative. That's telling me that the energy is being emitted. Okay. So I guess I should fill these in where Alex has asked me to. So what is the energy of the electron in the ground state? The ground state just means the lowest energy state. So that would be that 100 zeptojoules. The energy in the first excited state, well, where's the next thing we come to? That is B. So that looks like it's 450 zeptojoules. This particular electron is being absorbed because it is going up in energy, and we calculated that wavelength to be 441 nanometers.